They were on polynomials and calculus.
Polynomial and
Calculus. Differentiation, integration.
differentiation. Okay. So do you still have any inkling of the polynomial question?
I don't remember.
You cannot remember. Oh, okay. Not a single detail about the question.
Uh, no, I don't. I don't really remember other than
Ah.
they gave me one of the factors, then they asked me to find others.
Oh yeah. Okay. 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 And then
Uh,
okay. So for polynomial for polynomial basically you okay. So are you on? Yes, you're already on this. This is called mirror. Yes. So for polynomial it can't be too hard. Yeah, it can't be too hard because for polynomial basically let's assume a cubic polynomial, which is a very popular. Is it polynomial or binomial expansion?
uh,
They give you a factor.
oh,
Okay. So for cubic polynomial, I guess this is a very popular question for your level. Okay. So they look like ax to about 3 plus bx to about 2 plus cx plus d. So this is the cubic polynomial you should look for. And if they give you a factor, so let's say if they give you x minus 2 is a factor, okay, and then all you need to do is just sub in, so you f2, so you should get 0. So that's a factor by factor theorem, right?
yeah.
Yeah, and then you put the 2 in, then you should get 8a plus the 4b plus the 2c plus the d. So that's your first equation. Okay, and by just giving you one factor, and then I don't think you can finish. I mean, I don't think you can solve. Okay.
Okay.
So another way to do this is, of course, if you I'm not sure if you know your fx, which is your function. Do you know the function, or they
I don't
ask you to
remember.
huh? Okay,
I don't
cannot
remember.
remember.
Yeah.
Okay, never mind. So basically what I'm telling you is method one is bifactor theorem. Okay, method two is you do the long division. So if you have the function fx, so just write it down here. Actually, it's good to have the one of the factor, because once you get the x minus 2, right, you can do the long division. You can do long division, da da da. Then you can, then when it's a factor, you're not supposed to have any remainder, right?
Yeah.
Yeah. So once you get this, and then you will know that, hey, my this fx is actually equals to x minus 2, and then of course this is your quotient, right? Right. So you times your
Yeah.
quotient.
That's
So
good.
usually your quotient will be what? Usually your quotient will be so
So,
your quotient will be in the quadratic format already, right?
yeah.
Yeah. So once your this quotient is in quadratic format, I think it's pretty easy for you to continue to solve, because basically you're solving quadratic equation now.
Okay.
Does it make sense?
Yeah.
Okay. So for polynomial is really hard to be very hard. But I think I talk about there is a question, right? They ask you to solve, well, if 2x to the power 3 plus 2x2 plus x plus 4 is equal to 0, and somehow you get the x is equal to 1, x equal to half, example, x equal to negative 2, then they ask you, what if you have the 4x to the power 3, then plus x to the power of 2, then you have plus 2x, then plus 2 equal to. You remember this question?
I don't remember.
You don't remember this? The
No.
other time? And then I asked you to help me check, and then it should. Can you see hands? They basically, you need to use hands.
Oh, oh.
Ah. So
Yeah.
can you see the,
Yeah, yeah, I
yeah.
remember now. The coefficients are all just flipped around.
Yes, yes. Okay, so this is this. Then this is your this. This should be 2, yes. So this 2 is be 2x, and then this x cube is be 2. Okay.
Yeah.
So therefore, so over here you have this. Over here this factor is x minus 1. Then over here is x minus half. Then this one is x plus half, right? So just flip it around. It will be what? It will be half x minus 1, right? Then half x plus 1, right?
Yeah, and then 1 plus x.
1 minus x, right? Something like that. And you can actually double check. You can also double check. Alright?
Wouldn't it be 1 plus x?
1 plus. Over here, right?
No.
So
Yeah.
this one replaced by 1, right?
But then you
So
have
your
half
this
plus x,
minus
right?
1 is
Half x plus 1.
no. Hold on. This one will give me half x plus. Okay. So maybe I link properly. I mean I link wrongly. So minus 2 should give me. Okay, which one is wrong? Over here is half plus 1. Yes, over here. This one is this.
Okay.
Okay. Okay.
Okay.
Actually, you can double check with the calculator, right?
Yeah.
For to double check. Yeah. Okay. So polynomial is yeah, this is the very common question. And the other one is differentiation or
Yeah.
area under the,
Differentiation integration.
like what kind, like area under the curve or
No.
mm.
They just give me an equation, then I have to differentiate, and then
And you
with a
can't.
hand, and then integrate.
Oh, okay.
Yeah, it was a pretty
Yeah.
long expression, so I
Ah.
didn't
Oh,
find
okay.
out.
So for a long expression, is it like trigo?
Uh, yeah, it was
Mm.
trigo.
Okay, I think for trigo, right, what they like to ask is they like to give you a very complicated trigo function. Then after that, they will ask you to prove. Okay, so maybe they will give you a very complicated, I don't know, like tangent square x plus secant square x, and then they ask you to prove is equal to a very simple, maybe tangent 2x, that kind of thing. Yeah. So
Yeah.
if you can, so basically this is very complicated. But actually, if they ask you to differentiate your left hand side, right? Your left hand side, right? You can actually differentiate your right hand side actually, which is much simpler, yeah? Right?
Mhm.
Is it this type of question?
No, it wasn't approved questions.
Pardon?
It wasn't approved questions.
Oh, it wasn't proof. Oh, okay, okay. So never mind. So I'm not too sure. Like if they give you something this complicated, and then yeah, and then you probably want to okay. And if they give you a very complicated one, so the techniques actually we seldom talk about differentiation. Did we do any differentiation question before? No, right? Together.
No.
Yeah, you see, okay, never mind. So I think it's good to talk about the techniques of differentiation for your level. So basically there are three types. Number one, two, three. Train rule, second one. Then this is term by term. Then this is product, right?
There's also question what?
Yeah, yeah, I understand. But actually quotient is actually product. I mean you can see
Oh.
as product. Okay, so I'm going to give you an example. So let me just pick one question and then we talk about it. So basically, you have to get that whatever function, right? That complicated function, you can only solve it by this way, or this way, or this way. Okay. For the quotient rule, right? Let's say you have this let's say you have this one, right? So let's say you need to differentiate this. What you can do is that you can do it the product rule. Why? Because you can see this as this, right? You can bring this on top, so that is negative 2, right? Right?
Yeah.
Then after that, you can just get your u equals to 2x, get your v equals to this, right? Then after that, you get a du dx, or is it's faster to just do a u prime is 2, v prime is negative 2, then 2x plus 1, then bring the power down, then after that minus
minus
1, right?
1.
Then after
Yep.
that you have the this, you have to steal
And
times 2,
times
right?
2.
So
Yep.
it's, yeah, okay. So after that you just cross multiply, right? So you get 2 2x plus 1 negative 2 minus this times this is 8x, then 2x plus 1, then minus 3. Okay, so of course you must be thinking, hey, do I have to simplify or something? What do you think? Do you need to simplify?
Uh,
It really depends. Actually,
yeah.
for me, this is good enough. Okay, but uh, for some teachers, they might be very particular, so they want you to get it into this format, right? And I hope you can see that if you need to combine into a single fraction, you need to combine it into a single fraction. What you need to do is like you need to times the 2x plus 1 here, right? So therefore you need to
Yep.
times the 2x plus 1 here, right?
Yeah.
And then after that, what you do? So you need to open the bracket. So 4x plus 2 minus 8x. So over here is this. And then after that you have this minus 4x plus 2. 2x plus 1.
Okay.
Okay? So this,
Yep.
by the way, this answer looks very neat. Yeah, of course. But usually if I don't have the time, I'll just stop at here. They can't they can't
Okay.
uh they can't fault me for leaving the answer in this format. Unless they need to ask me to express in a particular, especially in a particular format. Sometimes they will say, please prove it to be like this, Okay.
Okay.
Yep. So this is by like you can use quotient rule, but instead of memorizing one more rule, I just stick with product rule to solve this. Make sense?
Yeah.
Okay. So yes. So probably just let's talk about differentiation today. So since we have not talked about that, so let me just go and find a question from your material. Sharing folder, your material, tutorial. Differentiate the following. Okay. So which one shall we look at? Let me just pick one, then we talk about it. Find that, then hence evaluate. Oh, there are a lot of differentiation question here. Okay. Okay, I'm going to just drop it here. Can you see this one?
Uh, yeah.
Question 8. Okay. So over here, you're asked to differentiate the following. So you have the exponential. So for exponential, right, you will end up with the same thing. Okay. For exponential, you end up the same thing. Then, but you still have to differentiate. So for differentiation, is like you need to see that, oh, first I have to differentiate this whole thing, and I will get this one, and next I have to differentiate over here. Then I will get what? Negative 2x, right? And then that's all, right?
Mm,
It's like
yeah.
peel back the layers. Okay, one layer, second layer, and then like peel all the layers until you finish it. Okay,
Okay.
so therefore for this is negative 2x e to the power of negative 2. Yeah, this one. Okay.
Okay.
Then for the second one, the first one is very clear cut. Is is a train rule. Right?
But isn't this product?
Oh, product. Yeah. Sorry. Product. Yes. Why? Because it's a product of two terms. Yeah. So
Yeah.
that's also one way for you to identify what you need to use. Okay. Okay.
Okay.
So u equals to tangent 2x, then v equals to sine 2x. Then of course the good habit to have is you just write down what is differentiation of sine. Okay, you don't have to write sine 2x, just sine x. It's cosine, right?
Yeah.
And tangent x is? I cannot
Secant
recall already.
square.
Secant
Is it?
square?
I'm not sure. So.
Yeah, I cannot recall. So, and it's not given, right?
No, it's not.
Okay, let me just quickly differentiate. This is called what? Differentiate trigo. Okay, I'm going to put them all here. I have it here already. So I guess this is not a exhaustive list, not complete, but I think it's good enough for our practice here. So we are doing tangent, right? So yes, secant square. X. Oh, I still can recall. Very good.
Oh.
Okay, right? Yeah.
Yeah.
So therefore, so it's always good that you put your this formula, not formula because it's not given. So you need to recall and then write it somewhere at the start of the lesson. Then just whenever you do differentiation, you just put it here and then try to do it. Okay. So this tangent 2x is secant 2x, and you still have to differentiate the 2 inside, and you get 2. And for this is the 2 is cosine 2x. And differentiate 2x inside is 2. Right? So cross multiply.
Yeah.
Okay? That's it. Okay? That's it. Of course, it really depends whether you want to simplify them or not. If you want to go ahead and simplify them, I think you can, because this is your sine 2x, cosine 2x, cosine 2x. So this is gone, right?
Yeah.
So for this one, is there a way for you to get rid of something? Let me see. Sine 2x. Sorry, no.
It becomes tangent.
It becomes you have
You
one
know.
tangent and then you have the sine, so it doesn't help a lot. So it's okay. So probably it's like
Wait,
this.
secant square 2x. I can change it to tangent, right?
Yeah, you can do choose your tangent, but it doesn't help much. You still have to. Or I'm not sure if like they want you to. Maybe sometimes they will ask you to like like prove it is equal to certain thing.
Okay.
So I take out the common factor. But anyway, yes. So we are not talking about get it into a particular format. We focus on the approach of differentiating here. Okay, so that's how you do the differentiation. Then the last one, which is the ln. Do I have the ln next to me? It's 1 over x, right? Yes, so it's 1 over x. So for this one, you can see it this way. So you have this x plus 1, x minus 1. Then to the power of square root is 1/3, right?
Yeah.
Cube root is to the power of 1/3. And I think you can bring the 1/3 down, I mean to the front. Remember?
Oh, it's long.
Yeah. Remember?
Yeah.
So then yes, you just okay. I think you can do the factorization inside x squared minus 1, right? Okay.
Yeah.
Then after that continue. So when you differentiate, basically the one third you can take out because it's constant. So now what you do is it's 1 over x 1 over x squared minus 1, and then you still have to differentiate the. So this is the first thing you differentiate. Then this is the second thing you differentiate, which is 2x. So that's why you end up with this answer after differentiation. Does it make sense?
Yeah.
Okay. So yes, that's how you differentiate the all these all these questions. So the curve has this, and then given that the tangent to the curve is parallel to the line of this. So find a way. Is it this kind of question, or just like a direct differentiation?
It was a direct differentiation.
Oh, okay. Okay. Because for differentiation question, right, usually they like to ask you a question something like this instead of just ask you to. Very seldom they will ask you to differentiate this. Very
Okay.
seldom. Okay. So um this differentiation question looks easy. So let's see if there is a more interesting one. Oh, they asked me to show this. Differentiate the following with respect to x. And so far, all the differentiation I'm looking at here from your revision materials, they are quite friendly, to be honest. Yeah. Oh, this one. Okay, I picked this question because this is the question that sounds very familiar to you. Maybe it's a polynomial, so they don't give you the entire function. They just give you a factor, which is here, and then they also
Okay.
give you a remainder divided by this. Then they ask you to find a and b. So basically, a and b, I think you know two unknowns. So you need
Two equation.
two equations. Yeah. So basically, this is the hint. Like two unknowns, two equations. So you need to solve simultaneous equations. So your goal, um, your goal should be to form two equations. Okay. And then
Okay.
the first equation will come from this, and the second equation will come from here. Make sense?
Yeah.
Yeah. Okay. Okay. I'm not going to solve it. So we are talking about approach here. So um, then I'm looking at which. Oh, yeah. So maybe I should do this question together with you. Because today, one student asked me the similar questions like this. So sine 2 theta plus 30 degree equals to negative half. Okay, so a lot of students they miss the okay. Some students they miss one of the answers or they miss two of the answers. Yeah. So I want to emphasize one more time how you can ensure that you don't miss any answer. Okay. Okay.
Okay.
So when it comes to trigo angle, right? So I hope you know that maybe we just we we are not digressing from this. We just talk about something uh not really you can consider is related to this, but it's a bit far away from this question. But the fundamental for this is, let's say if you have a angle 40 here, I hope we actually we talk about the angle 40 this position, right?
Uh-huh.
Actually the angle, so you add 360 to it, so angle
Yeah.
400 also refers to this direction,
Yeah.
and then if you add another 360 to it, so angle 760 also refers to this position. Okay, so meaning what?
Okay.
Meaning angle 40, 400 and 760, they might not be of the same value, but on this, if you consider this quadrant, right, on this quadrant thing, right, they refers to the same position. Okay.
Okay.
Okay, so if they refer to the same position, that means um in terms of trigo, they are equal, in a way. But to convince you they are equal is very hard. Like, what? You're telling me what 40 is equal to 400 is equal to 760? It doesn't make sense, right? But
Yeah.
but the thing you want to put here is probably you want to tell yourself, to convince yourself and to others is because they refer to the same position.
Okay.
Same position in trigo. So by writing this down, I think it's easier for you to accept, right? Okay?
Yeah.
Then, therefore, if you don't have a range, so let's say if there is no range here, your angle 40, you add plus 360, you can get 400, then there's no end to it, do you know?
Yeah.
So there's no end. So basically you have infinite number of answers if there's no range, right?
Yeah.
Okay. So the first thing we need to do whenever we do solving questions, so now we come back to this. So if we are asked to solve this, you know, when we asked to solve this, the first thing you need to do is you need to establish what's the range. If you don't give me any range, if there is no range given, right, that there are infinite number of answers. Okay, make sense?
Okay.
So
Yeah.
therefore, usually they will give you a range. So they tell you, oh, I want theta from maybe 180 degree to negative 180 degree. So actually, basically, they what they are telling you is, I want this range. Okay, anything
Okay.
beyond this range, you don't need to give it to me. I want angles between this range. So, but the funny thing here is what they over here is the range for theta, right?
Yeah.
Okay, but over here is 2 theta plus 30, right?
Yeah.
Okay, so actually, if I did not talk about this in detail last time, I want to make it clear once and for all from today onwards is you need to get the range of 2 theta plus 30. So how? So just
Oh,
so
times two.
so establish, basically the first step actually is establish the range. You know why we need to establish the range first, right? Because if we don't establish the range, we are going to have an infinite number of answers, which is not what the question wants, right? So
Yeah.
theta is for this range. Okay. So 2 theta is 360, negative 360, right? Okay.
Mm-hmm.
So 2 theta plus 30 will be 390. Then this will be minus 330, right? Does it make sense?
Yeah.
So yes. So basically the range is this for the 2 theta plus 30. Does it make sense now?
Yeah.
Okay, good. So with this, right? Okay, with the range established, I think it's pretty easy already. Just solve it like normally. So, this sine 2 theta plus 30 equals to this. So the first step you do is sine inverse. Can you help me out? Sine inverse negative half. If I'm not wrong, it's negative 30.
And negative 30. Wait, but I thought if you were taking the basic angle, it should always be positive.
Yeah, so yes, hold on. So basically, if you talk about this, so this is called sine negative, right? Can you see? Sine negative.
Yeah.
So now sine negative is, if you use the all science teacher are cool. So sine negative is the T region and the C region, right?
Yeah.
Okay, so therefore, so you just write down this is negative 30 degree. So negative 30 degree, so T region and C region. And the formula for T region is 180
180
plus
plus.
alpha. Then this is 360 minus alpha, right?
Yeah.
Okay, good. So now, like we talk about, whenever you have a negative degree, if you can actually continue to add, so we don't want to play with negative value. Okay, so we want to play with positive value. So when
Yeah.
you play with positive value, you add 360 to it. It refers to the same position, right? So therefore,
Yeah.
the answer actually is 330. Okay, right?
Okay.
So that
Yeah.
means negative 30 refers to the same position of 330. So 330 is in the C region. I hope you know. So therefore, 330 is equal to 360 minus alpha. So therefore, alpha is actually 30. So therefore, you put alpha back to this. So another answer is
10.
210, 210. Okay. So now,
Yeah.
the interesting question is, so basically, okay, so sine 2 theta plus 30 equals to negative half. So basically 2 theta plus 30 is equal to this one and this one, right?
Yeah.
Okay, so let me continue to write it down. I'm going to space them apart a little bit. Okay, so now your job is, like I say, right, 210, and if you add 360 to it, which is 570, it refers to, I mean, 210 and then 570, they refer to the same position, right?
Yeah.
Yeah, so I add 360 to it. And then, similarly, I can add 360 to it. I can also minus 360 to it, right? Because
Yeah.
it refers to the same position, right?
Yeah.
So therefore, 210 minus this is minus 150. Help me out if I, because I'm doing this mentally. So help me out if I get, I might, get the answers wrong because I'm doing mental calculation. Okay.
Okay.
So you have this minus 150, which refers to the same position as 210. So now continue with this plus 360. So you will get 690 over here minus 360. You will get minus 30, right?
Yeah.
So now then you ask yourself, okay, you have four sets of answer. Of course you can continue, right?
But if you minus 360, you just get the same one.
No problem. Then I mean, I'm just trying to tell you, you can actually continue. You're right. You actually continue to do the plus 360 and minus 360 to these four answers. But if you look at your range, now you need to talk about the range already. The range is this.
Yeah.
Okay? The range is this. So if you look at the range, this is the range. And then you can actually filter out the ones that are out of range. 570 out. Right? Minus 150 in.
In.
690 out. Minus 30 in. So
Yeah.
210 in. 330 in. So actually, if you continue to do it, you realize since this is out, right? It doesn't matter. It doesn't matter for the, if you call it the children of this, it doesn't matter anymore,
Okay.
right? Does it make sense?
Yeah.
So for this, the
Yeah.
690, if you consider this as the father or the mother, so the children, because this is the, you add 360 to it, you minus 360, it actually is the derivative of this 690. So I call it the parent. So the if the parents don't matter, of course the children don't matter. So it's like
But the minus would, I
the
mean, it gives
minus
the
will
same
give back
answer,
the
but
same answer. Yeah. Okay. You
okay.
you you can do the minus. You get back the same answer, which is 330. Okay. Understand?
Yeah. Then
So over here the minus 30 is, yeah, it matters. Okay. So now if you continue this minus 150 plus, so like I say, you don't have to test anymore because this, you can continue, but you realize that's it. So therefore, you have four answers. Does it make sense? For
yeah.
theta, of course you need to continue to solve for theta. Okay.
Okay.
Okay. And one thing I want you to realize here is when we solve sine inverse, oh I'm sorry, when we solve sine inverse negative half here, the answer here actually is for this entire thing, right?
Yeah.
Yeah. So that's why when you add the 360 to it or the minus 360, you need to add to this one. You know some students, you know what they do? You know, they get 2 theta plus 330 degree equals to 210. Then they continue, they say 2 theta equals to 210 minus 30. Then they continue, 2 theta is equal to 180. So theta equals to 90, right? Okay. And you know what they
Mm-hmm.
do? Okay, so
The
I
plus
need,
360.
they go and plus the 360 here. Oh, so another answer is theta
Oh.
equals to 450. Then they check whether it's in range. So then they go and minus 360. Then this theta is equal to negative 270. So you're not supposed to add 360 and minus 360 to this 90 degree. The
Okay.
reason is
Because they already give the range for 90.
no. The reason is when you do this sine inverse negative half, right? Your this 330 is actually for the entire block. So you need to see this as an entire block. And then when you add the 360 or minus 360 to it, you should add the 360 or minus 360 here, not until you solve it.
But the range is also for the entire block. What? They give the individual range for theta only. Can't you use that for this?
Actually, yes,
out of range. What?
I understand your point. Actually, some students, right, they say, hey, you know the question give me in this range, right, theta, right? Right?
Yeah.
Right? So
Yeah.
they say, hey, can't I just solve this and then get the theta, and then after that I go and add the 360 and minus the 360. Actually, this way, mathematically, it's not right. I just feel it's not right.
But it gives the same answer.
Maybe for this question it gives the same answer. But I have ever encountered a question that they don't give the same answer.
Oh.
Okay? So
Okay.
we should always do things right, and then like start with the right approach. So the right approach is you can only add 360 or minus 360 to this answer. Not when you go until to the theta level. In this case, because in this case the angle is actually this whole block. The angle is this entire block, right?
Yeah.
The theta is actually just one component in this angle, in this block. So you're not supposed to add the 360 or minus 360 to the component of the angle. You should do it to the angle.
But the component itself also has a range.
No, okay, wait. They give you the range in theta so that you have the way to get the range for the angle.
Okay.
You get the point or not?
Yeah, but
Yeah.
if our answer doesn't fit the range that they give,
Huh?
I mean, if it doesn't, that means we're wrong, right?
Which one you're talking about?
The theta, our final answer, if it doesn't fit the range.
Oh, wait. I'm not talking about whether this 450 and this minus 270, right, actually is in range or not in range. I'm not talking about that. I'm talking about it's not right to add the 360 or minus the 360 to the theta.
Okay.
I'm not talking about whether this, your theta equal to 90, and now you go and add 360 to it, and then you minus 360. This is 450, this is negative 260. I'm not talking about whether this one is in range or out of range. I'm not saying this is out of range, therefore it's not the answer. I'm saying that. I'm saying the fact that you go and plus 360, this approach of adding 360 to 90 minus 360 itself is wrong.
Okay.
I'm talking about this approach is wrong. You add the 360 and minus 360 to the component of the angle is wrong. While you're supposed to add 360 and minus 360 to the angle, which is the entire block, which is 210. You get the point?
Yeah.
You get the point? Yeah. So I'm not talking about, this is out of range, that's why it's not needed. I'm not talking about that.
Okay.
Okay? So therefore,
Yeah.
next time if you ever encounter such question, you add the 360 and the minus 360 to the angle. Okay? Not the component of the angle. Because next time, maybe you can encounter a very complicated, I don't know. It can be so complicated. I don't know how complicated it can get, but yeah. So you need to add whatever answer you have, right? You add it here. Or minus 360 here. Not to the theta level, okay?
Okay.
Okay? Yeah.
Yeah.
Okay? So hopefully I make myself clear once and for all. Okay? Good. So this is the question I encountered today. Okay? Okay. Okay, let's take a look at let's see if I have an interesting question. Hold on, huh? Okay, this queen. Okay, good. Okay, I have a question here, which is asked by my student. And you seldom need to do this kind of question because you have a graphical calculator.
Okay.
Okay, it's a sketch question. So you are asked to sketch this y equals to log 5, right? Okay, and then you are asked to sketch y equals to 5x. I know some of the teachers ask students to memorize the basic curve. Okay, but
Yeah.
for me, I just don't bother with that. I just do what? I just give myself a table.
Oh.
So when x equals to, I give myself some negative value. Oh, log cannot be negative, so never mind about it, right?
Yeah.
I mean, I'm talking about the log 5x. Okay, so probably you have x equal to 0. Can it be 0? Cannot, right? Yeah, so no. So
Yeah.
start from 1.
Oh.
So can you help me out? Log 5, 1, what do you have?
Log 5, 1.
I mean
Okay.
log 5, 1. So it's log 1 over log
0.
5. Is 0? Okay,
Yeah.
good. Then log 2. I mean, yeah, log 5, 2.
0.43.
0.43. Good. 3.
0.68.
Maybe I
Okay.
should jump a bit, like 5.
1.
Okay, good. So then yes, that's how I can sketch. So when x equal to also 1, 2, 3, 4. So when x equal to 1 is 0, right? Right? Yes. So
Yeah,
when
it is.
so this is, oh, it takes so long to hit 1. So I just want to get, so maybe this is 0.5, then this is 1. So when it hit 5, then it's 1, right?
Yeah.
Here, right? So this is 0.43, this is 0.68. Okay, so it's like this. Okay. Then okay, let's test one more time. What about 7?
7. 1.2.
Oh, okay. So it start to plateau already a little bit. Okay. Yeah. So this is the y equals to log 5x, right?
Okay.
So just give yourself a few values, then you will see the trend. Because I just want to differentiate whether it's this one, or it can be this, it can be like this. I'm gonna give you another. It can be like this, you understand?
Yeah.
Yeah. So I just want to see whether it's this curve or that curve. So in this case, it's not the blue one, huh? So not the blue one, right?
Wait, wouldn't it have an asymptote? Or is that only for ln?
Asymptote. Okay, good. Very good. So when you want to ask the asymptote, right? Very good. So let's test for 0.5. Very good. Actually, I think I have not displayed what the question want also. Because I realize I still can continue from here, Understand?
Yeah.
So maybe the asymptote is your y-axis. So let's test. 0.5.
Log 5, 0.5. It's
Log 5.
negative.
Yeah.
Negative 0.43.
Okay, continue. Like really, really small. Then I know already. 0.01. Log 5, 0.01.
0.0. Negative 2.8.
Negative 2.8. Okay, yep. So that looks like the case. So the asymptote is your y-axis. Does it make sense?
Yeah, because they
Yeah.
can never touch
Yep.
0.
0, yes. Okay. So yes, you are right. I have to show the asymptote. Okay. So the blue one, will fill up the will enable me to continue. Okay. So this is your log. Yeah, this is your log 5x. So yeah, the asymptote is y. The
Okay.
y-axis. Okay. So the asymptote, which is I mean what's the meaning of asymptote is
It never touches.
yeah, which is very very, it's the limit lah, it's the limit, which is the limit. The meaning of asymptote is the limit, and then you can only get very very close to. Okay.
Yeah.
Okay, good. So that's how you graph this log 5x if you don't have a graphical calculator. Okay. Next, so for y equals to 5x, I think it's simpler. I think you can see, give it a negative 1, negative 2. So you have 1 over 25, right? So negative 1, you have negative, eh? Negative, it's never a negative, right? So it's 1, 5. 0 is 1, right?
Wait.
Y equals to 5x. So
5.
1 is 5, 2 is
It can be any number,
25.
what, right? It can't need to be any number.
No. I'm of course, but I'm saying like I need to give it some negative values and then give it some, then to get a sense of the graph.
Okay.
So negative 2, negative 1. So when the 0 is 1 here, this is oh no. So I need to get a longer. Let me just change the scale. So if this is 5, then this is 10. Then this is negative 5. This is negative 10. So in negative 2, so it's very small. Then this is 0.5. So basically it's very, I think I know the asymptote. The asymptote is the x-axis, I guess. Right?
Yeah.
25 is somewhere here. So this is the x-axis. So this one is. Okay. So asymptote. Okay, for this. Do you have to sketch them together? Indicate clearly the value where the graph crosses the x and the y axis. So indicate. So you need to indicate. So this is your 0 and 1, and you only have this point of
Wait, if
intersection.
something is the asymptote, how close can the line be to the asymptote?
What do you mean how close? Like what? You're asking for the value? Are you asking for this
Yeah.
distance?
Uh,
So basically, it's the limit. I mean, you want to go to like what? 10 to the power negative 100? No, right?
no, as okay, you see the table of graphs here. As
Yeah.
it gets closer to 0, y gets very smaller.
Very, very
So
down. Yeah.
yeah.
Yes.
So if x is 0, would y be infinity, negative infinity?
But it doesn't work. 1 over 0 doesn't work. And by the way, you cannot have log 50, right? We talked about it just now.
Yeah, but then how close could it get?
I don't know what is your meaning of close. Are you talking about like what? That means
It would be
if I give you 10 to the power negative 100, you will ask what about 10 to the power negative 1000? Then you would ask.
but it's recur. It's 0.0. The 0 can go. to infinity, right? It's 0.000001.
Yeah, no, you want to punch your calculator 10 to the power of negative 100? That's like 0.0000, like many zero. So if I give you this is this, then you ask me what about 10 to the power of 1000? Then another student might try to be funny. What about 10 to the negative 1 million, you know? Then 1 trillion. There's no way, there's no end.
If there's no end, isn't that infinity?
Oh yes, if you're
Then
asking about that, yes. Okay.
Oh, okay.
But when you ask the question, how close, then it's a very subjective question. How close? I cannot answer you with my knowledge, because my knowledge only can hit until here.
Okay.
Okay. Okay.
Okay.
So same thing. For this, you just have to understand that it gets very close to the x-axis, but never touches. Okay.
Okay.
Okay. So that's how you graph this too, and of course they ask you to indicate. So that's how you indicate. All right.
Yeah.
Okay. Then the student continue to ask me this logarithm, which is this. You want to try this out? Bi, yeah, on the left hand side. So you have finished all your end of year?
Yeah.
Wow. You know, some of my students, they are in the midst of doing their end of year, and you are the only one who have finished.
Oh,
Why you are so early?
I think because I'm in IP.
Uh-huh.
The
So
the people that are taking O level, they
yeah.
take it later than us. I think
Oh
they're at the
yes,
start or
yes,
something.
yes. They take it like not like they started early October, which is last week or this week. Yes.
Mm,
Oh, so yeah, so it makes sense. You guys, started earlier than finish earlier, and then definitely everything. You guys are on the. It's like you guys are on the highway. The rest is slow lane. Yes,
uh,
highway like oh everything speed up, speed up, speed up. For them, it's like in a traffic jam.
yours is log
Huh?
log 4 x.
Wait, what is this? I mean
I'm changing
this one.
log 8x into log 4x
You know log 8x into
into log 4x.
log 4x. Oh, okay.
Log 1.5.
But hold on, I don't understand. I don't understand this part.
Huh? Which one?
This one.
Wait, this is the change of base, right? Wait, log, isn't it log,
I thought log 4x, then log 4.
huh?
So when you have log 4x, you should have. You want to change to. So this is your 8, is it? So you need to write this as 8.
Alright.
Okay, so you want to change to log 4, 8. Yes, I understand. So it's log 4. X should be on top.
Oh, x on top.
Hmm.
Okay.
Then 8 below. Yes.
Okay.
Yeah.
It's 7.
Hmm.
What do you want? No, it's x squared over y. What's my y? What's the y that they want?
They want the... Oh yes, they have a y. So this is funny, huh? Is there any y here?
No, there's no y in the question.
Oh yeah, there's no y in the question. Are they related to the above?
I think they have to be.
Is it B part 1? No, right?
Do I have to change it to log 5?
You mean 5x?
Yeah.
If you talk about 5x, why not log 5x?
But they want the answer in log 4. I thought I had to change everything to log 4.
No, I'm talking about your this y. So you want to take this y as what? Which one? You want to take the y as y equal to log 5x? Or you want to take it as y equals to 5 to power x?
Log 5.
Then, okay, makes sense.
Log 4.
Okay, let me go and grab a drink.
What?
Actually, my Mac Mini is heating up.
Cool.
Because I'm doing recording, I'm doing this, but generally this is always the case. And then you get some ice so that it cools my Mac Mini. I think they have to give you the... So can you manage? But anyway, they never give you log 5 also, right?
Yeah.
Okay, so this... I think A? No.
But I don't know what log 5 is.
I know what log 5 is. It's Y.
But they want it in terms of P and Q, not in terms of Y.
In terms of P and Q only, right?
Yeah.
Oh, that's funny. This question, I'm not sure if there is a mistake to this question there. Then what about 5x? So let's say it's in terms of y, then you get it into 5x.
Yeah, I changed the y to 5x.
And then you end up...
Wait, can you take log of log?
Oh, this is an answer, okay? This is an answer. Log 5 is a value.
Oh, but there's an x.
Yeah. Can we accept x?
I can just change x to log something. What?
What do you mean by you change
I
x
can
to log?
change x equals to 8 to the power of q.
Oh, if you can, yes, go ahead.
Okay.
Yes.
8 of q log 4 or 5.
Yeah, done.
But that's very weird.
It's weird, yes, it's weird.
I can use 8 to the power of q. I can also use 4 to the power of p.
Yes.
Then why did they give me log 8x at all?
So, really, but it's okay. I think it's a good attempt here. Yeah, it's a good attempt here. At least you get it into P and Q. Yeah.
Okay.
Yes. Okay. Yep. Good attempt here. Okay. Good. So probably we take a brief break then before we come back and look at other questions.
Okay.
See you in a while, yeah.
Okay. Okay.